1,000 x to the negative 1, I'm bringing that up, minus 5,000 x to the negative 2, plus 100, and now I'm going to take the derivative of that. So p prime of x equals negative 1,000, and when I subtract 1 from that, that's going to give me x to the negative 2, but then I send him back downstairs, so that would be over x squared. Negative 2 times 5,000 is positive 10,000, but when I subtract 1 from that, that gives me x to the negative third. When I send him downstairs, his exponent changes. Now the whole idea about this is to set the derivative equal to 0. So I'm going to let p of x, p prime of x, equal 0. And what that means is I can kick that over to the other side and then solve for x. And I set this equal to 0. That's going to give me negative 1,000 over x squared plus 10,000 over x cubed equals 0. I'm showing every step. I'm not going to skip any steps on the review. So now I can add that to both sides, and that would give me 10,000 over x cubed equals 1,000 over x squared. Now I'm going to cross multiply and simplify. So when I cross multiply, I get 10,000 x squared equals 1,000 x cubed. One zero, 2 0, 3 zeros, that's going to give me 10 x squared equals x cubed. I'm going to bring that over to this side. That's going to give me x cubed minus 10 x squared equals 0. Factor out of x squared. So my two solutions are x equals 0. But notice in the problem, it says x has to be greater than 0 items, or x equals 10. So how many items should it make to maximize profit? The answer is 10 items. So number 2, the key for this one is to highlight the like items. So I have orange trees and every additional orange tree, so that's 30 plus x, and this is 500 oranges minus 10 oranges. So I'm going to set up my O of x equals 30 plus 1x, and that's going to be multiplied by 500 minus, because it's fewer oranges, 500 minus 10x. And now I'm going to FOIL that out and then set it equal, take the derivative and set it equal to 0. So let's see here. 500 minus 10x, 30x, so that's going to be 15, and 1, 2, 3 zeros. Negative 300x, positive 500x, negative 10x squared. So O of x, after I FOIL it out, is equals negative 10x squared plus 200x plus 15,000. I'm going to take the derivative of that, which would give me O prime of x equals negative 20x plus 200. Now, the key is, again, you set that derivative equal to 0. So I let O prime of x, I set that equal to 0, and that's going to give me negative 20x plus 200 equals 0. I add the 20x to both sides, so that's going to give me 200 equals 20x. Divide both sides by 20. That's going to give me 10. So this is tricky, so x equals 10, but there's already 30 orange trees in the grove, where if 30 orange trees were planted, so the amount of trees that I want to plant that should be planted is a total of 40 trees. A little tricky on the vocabulary. Number 3 is very similar to number 2, but notice again, I highlighted 20 copies, additional copy, so I don't know what we're going to call this, sales. So I think the answer key called this S of x equals 20 plus 1 copy. And the painting started at $100 each. But then for every extra one you sell, it goes down by $1. So that's going to be 100 minus 1x. Plus a painting minus $1. Negative x squared plus 80x plus 2,000. We're going to take the derivative of that and then set the derivative equal to 0. So s prime of x equals negative 2x plus 80. Set the derivative equal to 0. That would give me 2x equals 80, or 80 equals 2x. So that's going to give me x equals 40. Again, she can sell 20 copies, and that's it. This is great if she sold 20 copies, but she has to sell an additional 40 copies. So the actual answer is 60 copies. You have to add that to the original amount. So it's supposed to be 60 copies total. So again, highlighting the like items, 200 pounds, 5 pounds, down by 1 penny, and originally 90 pennies, 90 cents. So I don't know what to set this up as. We'll call this a price function or a pound function. P of x equals 200 plus 5x. I got that from the highlighted yellow. I'm going to multiply that by the original 90 cents minus 1 penny per day, or 1 penny per pound. Now I'm going to FOIL that out. So I need to find the expansion x. 200 plus 5x, that's going to give me 18, and 1, 2, 3 zeros, minus 200x, and then that's going to give me 45 and 1 0, 450x, minus 5x squared. So my p of x is going to equal negative 5x squared plus 450 minus 200, I believe is 250x, plus 18,000. I'm going to take the derivative, so that's going to give me negative 10x plus 250. Now I'm going to set my derivative equal to 0. And when I do that, I bring the 10x over to the other side, so that's going to give me 250 equals 10x. And now I see that when I divide both sides by 10, that x equals 25. Now, because I have x equals 25, I want to see what that means in the context of the problem. How much longer should the watermelons grow in order to fetch the highest price? So 25 is probably going to be a time. So and it's how much longer, not how long. So it says how much longer. So the x equals 25 is my answer. It should be 25 days should fetch the highest price. Another farmer, it says 400 feet of fencing. What dimensions x and y? So since I already have a y there, I'll put a y here, a y here, and a y here. And I'll label this side as x and this side as x. So the 400 feet, this is all going to add up to equal 400 feet. So I have 2 x's plus 1, 2, 3, 4 y's. And that adds up to equal a total of 400 feet. Now for me, I like to simplify this. This is going to give me x plus 2y equals 200. I just divided everything by 2. Now the area of this field is going to be the area equals length times width, which is xy. So I can solve this for x because that would be more convenient and substitute it back in for my area problem. So x equals 200 minus 2y. And I'm going to substitute that in over here in my area problem. So area equals 200 minus 2y times y. I'm going to distribute that and then take the derivative. So my area formula, and the deal is, it asks you maximize the area. So that's a clue that you want to take the derivative of the area. Area equals 200y minus 2y squared, because I distributed the y. Now I'm going to pop the derivative. So the derivative of the area is equal to 200 minus 4y. Set the derivative equal to 0 to get 200 equals 4y. Divide both sides by 4. So this lets me know that y is going to equal 50. So let's see. This side's 50, this side's 50, this side's 50, this side's 50. So that's 100, 200 from 400 feet. So that means x has to equal 100 as well. And 100 up here. So the dimensions are going to be either 50 by 100 or 100 by 50. Feet. 10y. Set that equal to 0. I'm going to set that derivative equal to 0, and that's going to give me 150 equals 10y. So y in this case is going to equal 15 feet. So let's see what happens. If this is 15, this is 15, this is 15, and this is 15, and this is 15, that's 30. 60 plus 15 is 75, and 150 minus 75 leaves me with x equals 75. So the dimensions that will maximize are 15 feet by 75 feet. Surface area. Well, they give me the volume formula, and they give me the surface area formula. And what dimensions minimize the surface area? So what that's telling me is I have to take the derivative of the surface area formula. So let's set up the volume formula. That's going to be helpful. So volume equals pi r squared h. But they tell me that the volume of this particular container is 16. So that's 16 pi equals pi r squared h. I'm going to divide both sides by pi. So that means 16 equals r squared h. Now I want to take a look at the area formula. This is surface area equals 2 pi r squared plus 2 pi r h. And notice, I have a lot of r's. I'm going to want to solve this for h. That way I can have only r's over in this part of the problem. So if I solve this for h, I'm just going to divide both sides by r squared. And now I can substitute this, h equals 16 over r squared, into the surface area formula for h. So my new surface area formula is going to be area equals 2 pi r squared plus 2 pi r times 16 over r squared. I'm going to continue to simplify that and work towards something that I can take the derivative of. So this is going to give me area equals 2 pi r squared plus, well, 2 times 16 is 32 pi. And this is going to be, the r's cancel out, and that's going to give me an r over 1, r to the first on the bottom. But instead of putting an r on the bottom, I'm going to bring it up here and rewrite it as r to the negative 1, because I'd like to do the power rule instead of the quotient rule. Now I'm going to pop the derivative. The derivative of the area equals 4 pi r minus 32 pi, because a negative 1 times 32 is negative 32. Then I subtract 1 from that, and that gives me r to the negative 2, but I'm going to send him downstairs. So that's going to be r squared. Now, I'm going to set the area equal to 0, the derivative equal to 0. A prime equals 0. So this is going to give me another equation. So that's going to give me 4 pi r equals 32 pi over r squared. I'm going to cross multiply, and I'm going to get 4 pi r cubed equals 32 pi. I'm going to divide both sides by 4 pi. That's going to give me r cubed equals 32 divided by 4 is 8. Inverse cube root. The radius is going to equal 2 in this scenario. Now, I need to plug that 2 in somewhere to find h. And notice it plugs in nicely to this. So what's 16 divided by 2 squared? That means h is going to equal 4. 16 divided by 4 is 4. So the dimensions are going to be r equals 2 inches and h equals 4 inches. Let's make a diagram to help us out with this. 600 square foot of area. What is the largest square bottom box? So I drew a rectangle, I drew another rectangle behind it, now I'm going to connect the dots. And it tells us that this box has a square bottom, so these two sidelines have to be the same. And we don't know what the height is. I know the formula for volume of the box is going to be length times width times height, so x squared times y. The surface area is going to be x times x for the floor, that's x squared. And then the ceiling, that's going to give me 2x squared. Now one sidewall is x by y. So then I have 4 of those, so that's going to be plus 4xy. Now it tells me the area equals 600. So I'm going to set that equal to 600. And simplify, divide everything out by 2, that gives me x squared plus 2xy equals 300. And now I want to solve for something. I don't want to solve for x squared, because I have 2 different variables. I'm going to solve this for y. So let's see here. That's going to give me 2xy equals 300 minus x squared. And then divide everything by 2x. So my volume equals x squared times this quantity. 300 divided by 2 is 150 over x. X squared divided by 2x is minus x over 2. It's going to give me volume equals 150 x, because the x is simplified, minus x cubed over 2. And what I would like to do now is take the derivative. So I'm going to pop the derivative, and that's going to give me 150 minus 3 over 2 x squared. I'm going to set the derivative equal to 0, and this is going to give me 150 equals 3 halves x squared. Multiply both sides by 2, that gives me 300 equals 3x squared. Sorry. Divide both sides by 3. This is going to give me x squared equals 100. When I square root both sides, I'm just going to deal with the positive solution. So from this, I get x equals 10. So this base is 10, and this base is 10. And this is square feet. Now I need to figure out what the y value will be. So I want to find somewhere where I can solve for the y value. And I think I have it up here. Notice, before I had y equals 150 over x minus x over 2. And I'm going to plug 10 in. 150 over 10. 150 over 10 is 15. And then 10 over 2. 10 over 2 is 5. So my y value is going to equal 10 as well. So the largest square bottom box will have dimensions that are 10 by 10 by 10 feet. Oh, that should have been an x there. So that's going to give me 12x. This is going to give me plus 4x squared. Sorry about that. That's a 2x. That's a 2x. 4x squared. So I have to also multiply this all by x. So 4x squared times x is 4x cubed. 16 minus 12 is negative 28x. But I'm going to multiply that by that x squared, plus 48x. Now I want to take the derivative of this. 12x squared minus 56x plus 48. And I'm going to mode 5 3 it. I'm going to type in 12 equals, negative 56 equals, and 48 equals. Now I want the decimal. So that's 3.5 is one of my possible answers. And 1.13 is my other possible answer. 1.131.5. Now, it's x cubed. You notice it's x cubed, and x cubed goes like this. Where's it going to hit a max first? At 1.1314? Or at further down the road at 3.535? I think we can all agree that that's going to be the maximum value there. So, I'm going to take that. Maximum value is what x should equal. So x should equal 1.1314 inches. I want to find the maximum volume. So to find the maximum volume, I take that and I plug it into the original equation. So it's going to be 4 times 1.1314 cubed minus 28 times 1.1314 squared plus 48 times 1.1314 times 1.1314. 24.258 inches cubed.